On this slide now, we show something else that is slightly different. We are going to calculate the value of our investment after 2 years. So we're not just working with 1 year now, but at the same time, we are still compounding n times a year. So that means within each of these years, we are still adding interest n times a year. So the formula to calculate the value of our investment after 2 years, if we have a look over here, if we took the initial value of the investment and we multiplied it by what we have in the bracket here, so 1 plus the annual interest rate divided by the number of times we compound within a year. And obviously what's in this bracket is also raised to the power of n. So this will apply to the first year, and then we have to multiply again by what we have in the bracket raised to the power of n. So to simplify this expression, we would have V naught, the original investment, times by our bracket raised to the power of 2 for 2 years, times by n, the number of times that we compound. So a more general formula, after t years, the value of our investment after t years, everything is the same as we saw above. Okay, n would be the number of times that we add interest within each year. Okay, the number of times that we compound within the year, and t would be the number of years that we are investing for. We need to ask now, how does all of this relate to the number e that we learned about? And remember, we looked at the function f of m, where we had 1 plus 1 over m raised to the power of m, and we said that as m was increased indefinitely as it approached to infinity, then the value of this function here tended to e. Okay, so if we take the formula we saw on the previous slide, which enables us to calculate the value of our investment, where we have compounding n times a year and we are investing for t years, and we then transform this formula as follows. All right, just having a look up here, this is where the change is coming in, and what we are going to do is we will have n over r, right, and with all of this in brackets will be raised to r times t. And because of our rules of exponents, we know that we can do this because n over r times t would leave us with n times t, which is what we have up here. All right, so it's possible to transform this formula as follows. And then what we're going to do, we're going to set w equal, identically equal to n over r. All right, so here we've got r over n. So with this stipulated here, r over n would become 1 over w, and n over r would become w, and everything else is remaining the same. So now what we say is, as n increases indefinitely, and remember n is the number of times that we are compounding within a year, okay, the number of times we are adding interest within a year, as that increases indefinitely, okay, the number of times that we do so, then with n tending to infinity, w will also tend to infinity. And we know, all right, taking this expression here, 1 plus 1 over w, all raised to the power of w. If w tends to infinity, All right. Then just as we saw when we worked with this function up here, the value of this will tend to E. All right. So what we are saying is that as interest is continuously added to our investment, okay, the value of this tends to E, and we can substitute E in for this expression here. So instead of 1 plus 1 over W raised to the power of W, we can instead write E. Okay, so rewriting what we have up here, except just replacing the relevant part with E, we now have a formula to calculate the value of our investment after T years when interest is continuously added. All right, and that formula is the initial value of the investment when you first invested, times by E, our number E, raised to the power of R times T. And R is the annual interest rate, and T is the number of years that you are investing for. Okay, so this formula and the number E, you can see, is very important when we have a continuous compounding process, when interest is being continuously added to our investment. So working now with an example, we have our formula that we looked at on the previous slide. If we assume we are investing 100 Rand for 10 years with continuous compounding at an interest rate of 5%, it's quite straightforward. We need to take these values and plug them into this formula here. So we'll end up with 100 times by E to the power of 0.05, which is our 5% interest, times by T, which is 10 years. And if we work all of that out, we will get a value of 164 Rand and 87 cents, which is the value of our investment after the 10 years that we are investing for. And this represents a 64.87% increase, because remember, we did start with 100 Rand, and at the end of the T years we now have that amount. So the difference is the increase, okay? And the effective interest rate is the 64.87% in this example here. Okay, we had a nominal interest rate of 5%, but because we are continuously compounding, in other words, we are continuously adding interest, the effective interest rate works out at this amount here.